Welcome to Let's STEM. Today we're gonna learn how to calculate oxidation numbers in a very practical way. And we start with pure elements. These are elements by themselves and their oxidation number is always 0. For example, sodium here has an oxidation number of 0. And what about O2? Same thing, because we do not care how many atoms we have in the same molecule. The important thing is that the element is not in a compound. So the oxidation number for oxygen here is 0. The oxidation number for iron is 0, and of phosphorus in P4 is 0. And now we are ready to move on to group 1 metals. These are alkaline metals: lithium, sodium, potassium, rubidium, cesium, and francium. And their oxidation number is always +1 when they are in a compound. In KCl, potassium has an oxidation number of +1. But now the real challenge begins, because we have to find the oxidation number of chlorine. And for doing that, we write an equation. We know that in a neutral compound, the sum of oxidation numbers is 0, and KCl is a neutral compound because it has no charges. This means that the oxidation number of potassium, which is +1, plus the oxidation number of chlorine that we have to find, and we write for that plus x, equals 0. And now we have to isolate this x. We write plus x equals -1, because we have moved this +1 onto the other side of the equation and we have changed the sign. And this is the oxidation number of chlorine, -1. Very simple. Let's move on. Na2O2. Again, Na, sodium, is a group 1 metal, so its oxidation number is +1. And now we have to find the oxidation number of oxygen. We write our equation, 2, which is the number of sodium atoms we have, times the oxidation number of sodium, +1, plus, we have 2 oxygen, so we write 2 times the oxidation number of oxygen that we have to find, x, equals 0. Now we solve this equation for x. 2 times 1 equals 2, plus 2x equals 0. We move this 2 onto the other side of the equation and we change the sign, plus 2x equals -2, x equals -2 divided by 2, x equals -1, which is the oxidation number of oxygen, -1. And now, group 2 metals, their oxidation number is always +2. These are beryllium, magnesium, calcium, strontium, barium, and radium. The oxidation number of calcium, which is a group 2 metal, is +2. And now we have to find the oxidation number of oxygen. We write our equation, +2, plus the oxidation number of oxygen, we write an x, equals 0. We solve this equation for x, plus x equals -2. And this is the oxidation number of oxygen. Now, MgO, same thing. Mg is an alkaline earth metal, a group 2 metal, so we write its oxidation number +2, and now we find the oxidation number of oxygen, +2 plus x equals 0, plus x equals -2, which is the oxidation number of oxygen, -2. And what about monatomic ions? Their oxidation number is the ion charge. For example, for fluorine here, F-, the oxidation number is -1, because this is the charge of the ion. For Ca2+, the oxidation number is +2. For O2-, the oxidation number is -2. For Fe3+, the oxidation number is +3. And I want to make you notice that when we write the ion charge, we write the number before and then the sign. Instead, when we write the oxidation number, is the opposite way around. We write the sign and then the number. And now we find oxidation numbers for oxygen. For oxygen, the oxidation number is usually -2, but it becomes -1 in peroxides like H2O2, which is hydrogen peroxide, the most common peroxide, or CaO2. These are just examples of peroxides. You know, peroxides are compounds in which we have two oxygens bonded by a single bond. And now we just consider the case in which oxygen has an oxidation number of -2. CO2, it's not a peroxide, so oxygen has an oxidation number of -2. And now we have to find the oxidation number of this carbon. We write our equation, we have two oxygen, so we write 2 times -2, which is the oxidation number of oxygen, plus X, which is the oxidation number of carbon, equals 0, because this is a neutral compound, it has no charge. Now we solve for X. 2 times -2 equals -4, plus X equals 0, plus X equals +4, because we have moved this 4 onto this -4, sorry, on the other side of the equation, and we have changed the sign. This is the oxidation number for carbon, +4. And now Fe2O3, the oxidation number of oxygen, as this is not a peroxide, is -2, and now we have to find the oxidation number for iron. We write again our equation, we have 3 oxygen atoms, so we write 3 times the oxidation number of oxygen, which is -2, plus we have 2 iron atoms, so we write 2 times the oxidation number of iron, which we have to find. X equals 0, because this is a neutral compound. And now we solve for X. 3 times -2 equals -6, plus 2x equals 0. We have that plus 2x equals +6, because we have moved this -6 onto the other side of the equation and we have changed the sign. And now we find the value of x equals +6 divided by 2, which is +3. And this is the oxidation number of iron, okay? Now, let's move on. H2O2, this is a peroxide, so we know that the oxidation number of oxygen here is -1, we write it, and we find the oxidation number of hydrogen. We have 2 oxygen atoms, and we write 2 times the oxidation number of oxygen, which is -1, plus 2, because we have 2 hydrogen atoms, times the oxidation number of hydrogen, X equals 0, because this is a neutral compound. And now we solve for X. 2 times -1 is -2, plus 2x equals 0. We move this -2 onto the other side of the equation, and we have that plus 2x equals +2. We isolate this x, and we have that plus x equals +2 divided by 2, and we have that x equals +1. And this is the oxidation number of hydrogen. Very simple. BaO2, this is another peroxide. We write the oxidation number of oxygen, which is -1, and we can find the oxidation number of barium writing our equation, or if we remember the rule, the oxidation number for group 2 metals like barium is +2, so we have just to write +2. HCl, the oxidation number for hydrogen is +1 with non-metals, and chlorine is obviously a non-metal, and it becomes -1 with metals. So here hydrogen has an oxidation number of +1, and to find the oxidation number of chlorine, we just write our equation. We have that +1, which is the oxidation number of hydrogen, plus x, which is the oxidation number of chlorine, equals 0, because that's a neutral compound. And now we solve for x. Plus x equals -1, and this is the oxidation number of chlorine. And now NH3. we have that nitrogen is a non-metal, and this means that the oxidation number for hydrogen is +1 here, and now we have to find the oxidation number of nitrogen. We write our equation, 3, because we have 3 hydrogen atoms, times the oxidation number of hydrogen, +1, plus x, which is the oxidation number for nitrogen, equals 0. We solve for x, 3 plus x equals 0, x equals -3, which is the oxidation number of nitrogen, okay? Then CH4, we have that the oxidation number of hydrogen is +1 because carbon is a non-metal, and now we found the oxidation number of carbon. We write our equation, 4, which represents the number of hydrogen atoms we have, times +1, which is the oxidation number of hydrogen, plus x, which is the oxidation number of carbon, equals 0, because CH4 is a neutral compound. 4 times +1 is 4, plus x equals 0. We have that x equals -4, and this -4 is the oxidation number for carbon. And this is an example of hydrogen with a metal. Lithium is a group 1 metal, so we can remember that the oxidation number for lithium is +1. And with metals, the oxidation number of hydrogen is -1. So we do not even need to write our equation, but if we remember just one oxidation number between these two, we write our equation and we find the other one, okay? Sorry, guys, LH3, aluminum is a metal, and the oxidation number of hydrogen with metals is -1. So now we can find the oxidation number for aluminum. We have 3 hydrogen atoms, so 3 times -1, which is the oxidation number of hydrogen, plus x, which is the oxidation number of aluminum, equals 0, because AlH3 is a neutral compound. We solve for x, 3 times -1 is -3, plus x equals 0. We have that x equals +3, and this is the oxidation number for aluminum, okay? And now we have moved to halogens, chlorine, bromine, iodine. Their oxidation number is usually -1, but it becomes positive with oxygen. In this case, we do not have oxygen. This means that the oxidation number for chlorine is -1. And if you remember, for group 1 metals like sodium, the oxidation number is always +1 when they are in a compound. Here we have HBr, the oxidation number of bromine, which is an halogen, is -1 because we have no oxygen in this compound. And the oxidation number of hydrogen with non-metals is +1. If we do not remember the oxidation number of hydrogen or bromine, we just can write our equation and find it, okay? I2O5, we have that the oxidation number of halogens is positive with oxygen, but we do not know the value. This is why we start with oxygen. This is not a peroxide, and this means that the oxidation number of oxygen is -2, and we write our equation in order to find the oxidation number for iodine. We have 2 iodine atoms, and we write 2 times the oxidation number of iodine, which is x, plus 5, which is the number of oxygen atoms we have, times -2, which is the oxidation number of oxygen, equals 0, because I2O5 is a neutral compound. And now we solve for x. 2x plus 5 times -2 equals -10, equals 0. 2x, we move this -10 onto the other side of the equation and we change the sign, equals +10, and now we isolate this x. X equals +10 divided by 2, which is +5, and this is the oxidation number of iodine, okay? Now, Cl2O6, this is again an halogen with oxygen. We know that this chlorine has a positive oxidation number, but we do not know its value. We know that this is not a peroxide, and this means that the oxidation number of oxygen is -2. And now we write our equation in order to find the oxidation number of chlorine. We have 2 chlorine atoms. The oxidation number of chlorine is X plus 6 oxygen atoms times -2, which is the oxidation number of oxygen, equals 0, because Cl2O6 is a neutral compound. We solve this equation. 2x minus 6 times -2 is -12, equals 0. We move this -12 onto the other side of the equation and we change the sign. So we have that 2x equals plus 12, x equals plus 12 divided by 2, which is plus 6. And this is the oxidation number of chlorine, okay? Now, let's move on. Fluorine. The rule is that fluorine in compounds has always an oxidation number of -1 because it's the most electronegative element on the periodic table. This means that fluorine here has an oxidation number of -1. This is a non-metal, and so hydrogen has an oxidation number of +1. And this makes sense because HF is a neutral compound and +1 minus 1 equals 0. So this is correct. CaF2, the oxidation number of fluorine in a compound is always -1. And calcium is a group 2 metal and its oxidation number is always +2 in a compound. And again, this makes sense because 2 times 1, which is the number of calcium atoms we have, is 2, minus 2 equals 0, and CaF2 is a neutral compound. Here we have MgSO4. This is a neutral compound, and the sum of oxidation numbers in a neutral compound is 0. We know that the oxidation number of magnesium here is +2 because it is a group 2 metal. The oxidation number of oxygen is -2, as MgSO4 is not a peroxide, and now we have to find the oxidation number of sulfur. We write our equation, +2, which is the oxidation number of magnesium, plus X, which is the oxidation number of sulfur, plus 4, as we have 4 oxygen atoms, times -2, which is the oxidation number of oxygen, equals 0. And now we solve this equation, +2 plus X, 4 times -2 is -8, equals 0. We have that +2 minus 8 is -6, plus X equals 0. And we have that X equals +6, sorry, because we have moved this -6 onto the other side of the equation and we have changed the sign. And +6 is the oxidation number of sulfur, okay? NO3-, this is a polyatomic ion, and the sum of oxidation numbers in a polyatomic ion is equal to the ion charge. This means that if we sum the oxidation number of nitrogen and the oxidation number of oxygen, that gives us -1 in this case, which is the ion charge for NO3, okay? We know that the oxidation number of oxygen is -2 because NO3- is not a peroxide, and now we have to find the oxidation number of nitrogen, and we write our equation, plus X, which is the oxidation number of nitrogen, plus 3, as we have 3 oxygen atoms, times -2, which is the oxidation number of oxygen, equals -1, which is the ion charge. Now we solve this equation, plus X, 3 times -2 is -6, equals -1. We move this -6 onto the other side of the equation and it becomes +6. We have plus X equals -1 plus 6 plus X equals +6 minus 1 plus 5. And this is the oxidation number of nitrogen, okay? Now, H3O plus, the ion charge is +1. We know that the oxidation number of oxygen is -2 because this is not a peroxide, and now we have to find the oxidation number of hydrogen. We write our equation. We have that 3, which is the number of hydrogens we have, times the oxidation number of hydrogen, X, plus 1, as we have just one oxygen atoms, times -2, which is the oxidation number of oxygen, equal +1, which is the ion charge. Now we solve this equation, 3x, 1 times -2 is -2, equals +1. Now we move this -2 onto the other side of the equation, and it becomes +2. We have 3x equals +1 plus 2. 3x equals +3. This means that x equals 3 divided by 3, which is +1. And this is the oxidation number of hydrogen, okay? For today is all, and in the next video we're gonna solve more complex problems about oxidation numbers. If this video was useful for you, please like, comment and subscribe. See you next time. Ciao!